Welcome to Video 3, which focuses on Chapter 3 of Big Ideas of Early Mathematics, Counting. The information in this video builds on the knowledge on creating sets, which was shared in Video 1, and the concepts shared around number sense in Video 2. The two big ideas identified in this video that teachers and adults should focus on to support the development of children's rational counting skills are: counting can be used to find out how many in a collection. Counting has rules that apply to any collection. We'll talk about 4 basic rules that apply to counting. In many ways, number sense and counting are so closely connected it seems they should be considered together. However, the Early Math Collaborative emphasizes how complex the concept of numbers is and how important it is to allow young children to construct their understanding that they devote a whole chapter to exploring a sense of numerosity. In this video, we shift to conversational words and symbols that are used to represent numbers and to answer the essential question of how many. Let's explore the big idea that counting can be used to find out how many in a collection. How much and how many are fundamental big idea questions that are so embedded in our everyday life that we often are not conscious that in fact we are doing math. Knowing and understanding how many, however, is a complex developmental process, which is closely related to the development of number sense discussed in our last video. Recall, there are 4 different ways we use numbers in our daily life: referential, nominal, ordinal, and cardinal. Finding out how many is the cardinal use of numbers. Counting to know how many is also closely tied to subitizing skills, or the ability to perceive small amounts of objects and know how many instantly without counting. Another connection between number sense and the ability to find out how many by counting relates to the concept of numerosity, or the quantity of things in a set. Learning to count meaningfully requires both memorizing arbitrary terms or number names, or rote counting, and rule-governed counting, or rational counting. Rote recitation of the number words is not the same as having a good number sense. Rational counting takes place only after children have mastered the 4 key principles or rules as follows. Stable order principle. Counting words have to be said in the same order every time. Because the order of numbers is conventional, memorizing the sequence is a prerequisite to the use of the stable order rule in counting. One-to-one correspondence means that one number is named for each object. This takes some practice and time for children to fully grasp, as they have to learn to coordinate the number words with their physical movement of a finger and the eye along a line of objects. To help children develop one-to-one correspondence, teachers with strong mathematical understanding are very intentional about making sure that all counting activities are linked to counting something. When children make an error, instead of telling them they are wrong, the teacher asks them if they are sure. The order irrelevance principle can be defined as no matter in what order the item in a collection are counted, the result is the same. This builds on the rule of stable order and one-to-one correspondence. Children who understand the order of irrelevance principle understand that the number words are applied only temporarily to the objects being counted and have nothing to do with the objects themselves. Understanding cardinality actually involves 2 different uses of number. First, the child applies the numbers to the objects being counted using the correct number sequence and counting each item once and only once. Second, Once the count has finished, the counter reuses the last number word she said during the count to name the total amount of the set. To find out whether a child has grasped this principle, we can ask, how many altogether? So the child names the last number that was counted and does not need to count over again. Or when asked, give me 5, the child counts out 5 items and hands them over as a set. When given more items to add or subtract from a set, the child can count on or count back instead of counting all. The child knows the quantity remains the same despite of the fact that the arrangement of objects changes. Each principle builds on understandings developed in the previous ones. Full rational counting with a strong grasp of cardinality up to 10 is a process that takes usually 2 to 3 years to develop. It is important to remember that overemphasizing rote counting to high numbers before the counting principles are established for small numbers is counterproductive. To help children develop strong foundational understanding of counting rules, it is critical to start with small numbers through many authentic experiences and mathematical conversations. For example, the daily routine. Counting activities such as taking attendance that involves objects and movement cues structure the number system for children. This picture shows an attendance chart with 20 pockets, 5 red and 5 white in 2 rows of 10. Sticks are used for every child to place into the pocket. Children can put their stick in any pocket, which emphasizes one-to-one correspondence. The attendance chart has 20 pockets broken into 4 sets of 5 to strengthen visual understanding of cardinality. Children can put their sticks in any pocket, which reinforces order of irrelevance as well. Calendar routines that have become the staple of many preschool classrooms, unfortunately, may not be an activity conducive to children's number sense and counting skills. The base 10 structure of our new number system is completely lost by the calendar format. There are many alternative ways to do calendar in preschool to help children see how numbers of the days in a month grow. For example, create paper link chains with a new link added each day to emphasize +1, or create a linear calendar for the month, moving a marker daily. This creates a stronger sense of time. Or put number structure and patterns in the children's bodies by including counting games, songs, and movement activities. It is clear that while counting seems very simple, it is really quite complex. Some questions for you to consider. Consider how counting is currently assessed. Do our methods provide insight as to the instructional needs of your students? What change, if any, are needed? Consider your calendar routine. What adjustments can be made to better support mathematical development?